2014 Physics Paper 1, Part A, Section 1, Multiple Choice, Question 8. Body initially at rest. Let's read and identify. In a space free of gravitational field explodes in two pieces. So, two pieces. Away from each other with the same speed. Same speed, very important. So we've read, we've identified, let's draw a picture. So here is our body, initially at rest. So U equals 0, and it's got a mass, and we'll call it mass total. So therefore its momentum is its mass total multiplied by its velocity. Because its initial velocity is 0, it has 0 initial momentum. So we put a little subscript I here. After it's exploded, here's our central point. Let's call it our center of mass. We have one piece moving off in one direction, and we have the other piece moving off in the opposite direction. Now, it says here moving away from each other with the same speed. So if this one has a velocity of v, this one has a velocity of minus v. Notice speed is a scalar, so the magnitude of the velocities is the same, but the direction is opposite. Now, in this particular case, we'll call this mass 1, and we'll call this one here mass 2. You'll note that m1 plus m2 equals the total mass. Now, quite simply, if the velocities are the same, the mass of this one must be equal to the mass of that one, because the final momentum has to equal the initial momentum. And so therefore m1 multiplied by v1, when you add m2 by v2, they're going to cancel one another out. Now the velocities are the same but opposite. So m1 v1 plus m2 minus v1. Again, this velocity here is the same as that one, but they're in opposite directions. They've got to equal 0. Now the only way that that can actually play out is, of course, if the velocities are the same. So, sorry, not the speeds are the same. Now let's have a look. The speeds are the same, the masses are the same. So they must have the same mass. They must be moving along the same axis. Yes. They must have the same kinetic energy. Kinetic energy is a scalar. So half mv squared in this direction, half mv squared in that direction is the same. They have the same momentum. Incorrect. The reason they don't have the same momentum is because momentum is a vector and it has direction. One going to the left has a negative momentum. So this is negative m1 times v. And this one here has a positive momentum, m2 times v. So that one there is the one, C is the one that's definitely not correct.